So I want to go over, I'm going to do 1, 2, 3, 4, 5 because I think that these are good examples of how to kind of start writing classes, and I want to go over these examples and talk about what it means to actually have classes again and just give you guys a reminder. And once I'm done with this, we're going to use this lab and the homework that you guys did, and that's going to be leading into the next lab, which is talking about how to break apart a file into multiple files and have them be more manageable. Because a lot of times you really don't want to have classes declared like all in the same file. You want to have typically as much separation as you can where it makes sense. And I'll talk a little bit about what the rules that we use are to help you decide when you should make a file versus putting it into an existing file. All right, so first thing, we're going to write a class that describes a circle, and it has a couple of functions here, diameter and circumference, as well as a setRadius function, which allows you to pass in a radius to that circle. And I wanted you to create two circles inside your main function, one that has a radius of 10 and one that has a radius of 25, and then print out the diameter and circumference. So when making a class, it's kind of like making a structure where you define the name of the class and the semicolon at the end. Like we talked about the syntax of this. And by default, I'm going to make a few public functions. So I'm going to make, first of all, a setRadius function. And this one will take a radius. And the function I will define in just a second. Actually, I'm going to define the function below, just to show you guys. I'm going to define a couple of these functions below and a couple of these functions in line, too. And then there's a function called circumference, which takes no arguments, and then a function called diameter. And it's going to have a member variable called radius. So at this point, I kind of want to stop for a minute and talk about naming variables quickly. Some of you guys may have run into some issues because you want to pass in an argument that's named something like radius, and you already have a member variable called radius in here. So there is a convention you can use when you're creating member variables that helps you with this, and it's kind of a good practice to start getting into using this. And some companies do it differently. For us, on Overwatch, we do a lot of this, where we declare member variables with an M underscore to indicate this is a member variable. We put an underscore just to insert a space between the two, so there's a syntax of M underscore radius. This is just a name. You could really do anything you want to here. Like you could do this. Again, like this, if you had to use this everywhere. The key is that you want to distinguish this variable here from typically the constructor variables that you're passing in, so that when you're writing this function, you don't get confused over which one is the member and which one is the argument that's passed in. Now, C++ will typically try to figure it out for you, but you don't want it to be ambiguous to people reading your code. So in this case here, I'm going to make this guy a member. Another thing that I didn't really talk about yet, but I want you guys to start using too, is you typically, when you're declaring member variables, the general rule of thumb is that member variables should be marked as private. And the reason is that you really don't want people that are using your object to be fuddling around with the radius any other way than calling this function. And it's a little bit weird because it makes it seem like it's an unnecessary restriction, but the reason mostly is that you yourself, as a person writing this circle class, might want to store variables and manipulate variables differently than other people would want to use them. And oftentimes when you want to manipulate a member variable, you want to do more than just like set the member variable. And so maybe in this case, every time someone calls setRadius, you want to write something out to the screen that says that the radius of the circle is now 10. And if you make this variable private, you can do that, because once I make this thing private, remember, no one outside of this class, and no one outside of any class that has this private, outside of the circle class, can actually access this radius variable directly. Which means that when I use this, when I create a circle here, and I try to do circle A dot M radius equals 10, I can't do this because that thing is private. The only way I can set the radius is by calling the setRadius function. And the setRadius function is whatever I want it to be. So in this case here, I'm going to write the setRadius function. And by default, I'm just going to set my member variable equal to radius. But that doesn't stop me from doing something like, oh, if I just include IO stream, and let's just say I want to do radius is now, like that. Anytime someone calls set radius, I can call this function too. Another really nice benefit, which isn't really super obvious right now, is that when you get to a really big project and you want to kind of debug who is setting the radius. You want to see who is actually changing the radius. Maybe there's a bug with someone changing the radius to something really bad, like a really bad number. If you have a function like this and you make this thing private, the only way people can change the radius is by you calling your function. So you can put a breakpoint here. That means that anytime, the only time that the radius variable, member variable changes is through this function. If you put a breakpoint here, you will catch every single call to changing radius. You'll never miss a call to someone that changes the radius. So this is why my rule of thumb, and typically like the book will also kind of push for this, is member variables should always be private, while most functions that are member functions will be public, with the exception of a few functions that you want to declare that are used by only the circle, and I'll get into that later. So here's my set radius function here, and notice I declared it outside of the class. So here's the class, and here's my set radius function. Remember that if you wanted to implement a function that's defined in the class, you put the name of the class and then put 2 colons for the scope operator, and then the name of the function. And you don't have to do it outside of the class. You can declare it inline in the class too. So I can do this. So circumference is 2 times pi. I'm just going to hack this for now. So the circumference is 2 pi r. And this pi variable, I went over this with a few people. You can actually include a header file that it will declare this pi variable. Sometimes people will just say, like, you can do this, where you can create something called a define, which says my pi variable is 3.1415. And once you do this, notice how it turns purple, which means that anytime that you have this in your code, it'll actually just replace this with whatever comes to the right of it. I'm going to get into more details about this stuff here, but if you see this kind of defined, if you look it up on the internet, you might find people saying do this kind of thing. All that means is that you're going to replace this define here with 3.1415. All right. And then diameter, we can do the same thing, like so. And it's not radius, it's m underscore radius here. So these are my functions, and this is my implementation for my set radius function. And I can create a couple of circles. And then I can just print out like so, and I can just have it print out circumference, like so. Because this function returns a value, so it returns a float, I'm allowed to use it in the cout. And then diameter here. Okay. And then I can do the same thing for circle B. This is pretty straightforward stuff. The key is that if I want to call a member function or I want to access a member that lives inside of an object, remember you have to use the dot operator. However, if you're using a pointer, you want to use the arrow operator instead. Okay. And then we'll just do our And typically when you're working at home, you don't want to be writing a bunch of code like this. You sometimes get into cases where you'll have errors and you won't know where that error is, or it's kind of like a little bit difficult to find where it is. I would work on writing one function at a time at home, personally, just a little bit at a time. It really helps you organize your logic a little bit easier so you can tell when something goes wrong. So you can see here now, you can see how it says circle A has a different circumference than circle B and a different diameter than circle B. And notice here I'm spitting out when we call set radius as well. So you can, because set radius has this call here. Okay. Yeah. Go.
My iPad's working 10. We can find a babysitter on short notice.
Okay, here, take the lab before you go. I will give you all the lab.
Dang.
All right. I put it up in 213 for you, Dom. I can email it to you too if you need to
Yeah,
bail.
that'd be perfect, actually.
Okay, just I'll send it to you an email after class.
That'll work.
All right.
Thank you. Appreciate it.
Thanks for letting me know.
Yeah.
Okay, so that was number 1. Let's just do number 2, which is Pokemon now. And I'm going to do this in a separate CPP file. So I have all this stuff declared for a circle. And it's kind of more of the same. So a circle is a very kind of simple thing, but a Pokemon is just more member variables and more functions. So the easiest thing for me to do is I'm going to do a save as. And then I'm going to reopen console application. Let's remove this guy from the project and add this guy into. So I have my circle. I'm going to delete all this, and I'm going to delete all this for the Pokemon. So the Pokemon one was pretty much the same thing. I'm going to kind of go through this a little bit quicker. So it has a bunch of member variables and several functions to define it, calling set values and print info and get CP value. So these functions I'm going to declare all outside of the class. So like so. And it's going to have several member variables, which include, you need a string, so you're going to have a name, and you're going to have 3 variables for HP, attack, and defense. And then this member variable here is going to take those 4 arguments. Okay, like so. And then, so I did this really fast, but this is a really common thing. We probably have done this 100,000 times. If you want to write an implementation for a function, the easiest way is to grab the whole function prototype, copy this whole line, paste it here, delete the semicolon, put some curly braces in, and then take the name of the class, so Pokemon. I just usually just paste it in here and do colon, colon. And that way you don't have to rewrite this whole function with all the arguments, because the argument names remain the same here between those two. And it just makes it so you can do it super fast. You can do m HP equals HP, because this is a thing that you're going to be doing a lot. You write the prototype and then you write the implementation somewhere else, especially when you have multiple header files or multiple implementation files. You end up doing this kind of thing a lot. Same thing for print info and print CP. Notice I'm just going to copy both here, and I'm just going to write the implementation for both. And I'm going to grab this guy up here, which is the class name and the colon, colon, and just paste it there. And this makes it so that you write less code, copy paste as your friend as much as possible. And print info is just going to do, name. Actually do these on 4 different lines. And I'm going to do HP, attack, defense, HP, attack, defense. Okay. And this one's going to have, here's my print info. And get CP, I said, is going to be the formula of attack times the square root of defense. So return m attack times square root of defense. Okay. So now I have these functions. These are all the member functions. I want to create a few Pokemon. 3 Pokemon of my choice. So I'm going to create the starter Pokemon. So Pokemon is going to be Bulbasaur. And Bulbasaur, I'm going to call set values, which is going to tell me that his name is Bulbasaur. His HP is 50, his attack is 20, and his defense is 50. And then I'm going to create a couple more. And I'm going to name them differently. So this one's going to be Charmander, Squirtle. Do this. and Squirtle here. Yeah. Okay, so I've called set values on each of my variables here. So I'm going to now call print info. I'm going to just call print info on each of these. And notice here I'm duplicating as much stuff as I can because I notice a pattern. And then once I call print info, I believe I asked you to call CP value. And I can say, hey, Bulbasaur's get CP. And because, again, I'm going to do this 3 times, I'm going to copy the whole line. Do this 3 times. And I'm just going to steal the name here. And then the name here. And then here. If I was using an array, this would be a lot more straightforward. I wouldn't have to do this on separate lines, but I don't actually use an array until later. Looks like here I misspelled defense. Cool. So it's going to be a capital D. And I'm missing a semicolon because this is a semicolon here. Okay. So you can see here, name is Bulbasaur, HP, attack, defense, and each of their CP values are slightly different. So this is just more of the same, more member variables. So now I have a circle class and a Pokemon class. And I asked you to remove the setValue function and instead to create it using a constructor. I'll start with the Pokemon one and then I'll go back to the circle one because I have the Pokemon one open. So the difference is that when I'm creating these Pokemon, I have to call this function setValues, which passes in these arguments. But I don't have to call these functions here. What happens if I just don't do this, right? This program will still compile and run, but what will actually be the values that print out? Remember, it's like undefined values. We want to prevent this from happening. We don't want you to be able to use the Pokemon class and have all these bad values. So the way you can work around that is by forcing you to pass in arguments into the constructor. If I remove this function here and instead make it a constructor by deleting a return type and changing the name of the function to be just Pokemon, this turns it into a constructor. And I do the same thing here. And now instead of setValues, I have a constructor, which means now that I do this and I try to compile, it will not let me compile because it says that no default constructor exists for this class. It means that I need to pass in arguments into this class in order to make it work. So let me just go back and grab these arguments here. So here are my 3 functions that I'm calling. And instead of calling these functions, I actually just want to change these to be part of the constructor like that. And remember, I went over there's many different ways you can initialize values for variables via the constructor. You can use curly braces as well. You can use the equal sign with a curly brace. For now, I'm just going to use the classic style of doing parentheses and then all the arguments followed. And in here, again, I'm just going to do this. And I'm going to replace this. So now this has become a constructor. And now I'm not allowed to create a Pokemon unless I actually specify the values via constructor. And that forces me to specify values so that I get the same result. All right? This is really important because when you're making a class, let's say you're making like a class for a Diablo game or you're making like a weapon type, and you want people to make sure they specify things like the name of the weapon or like the attack value, you want to do that in the constructor. Otherwise, it's very easy to not do that. Like I can create a Squirtle and not realize I need to call setValues if I didn't have a constructor. All right. Okay, I don't think I need to go over the circle one. So, all right, now I use pointers to create your circles and point Pokemon. You can use the delete operator. So the key difference here is that right now I'm not using pointers. I want these all to be pointers. So I put an asterisk in front of there. And the interesting part about pointers is that it will not allocate memory for you automatically for the object that the pointer points to. In fact, it's pointing to nothing right now. And if you wanted to actually use a pointer, all you have to do is call new, specify what you're newing up, which is going to be a Pokemon, like so. Making sure at the end you also call delete on each of the Pokemon. And then anywhere we're using the dot operator, it's going to use the arrow operator instead. Okay, that's really all there is to it. Notice how little it changed from before. Before, remember, it looked like this. I was passing in arguments to the constructor right there where I declared the variable. As soon as I make it a pointer, I need to call new. Now, you don't have to call new on the same line. You can create a skirtle here, and then you can say on the next line, you could say this. Or you could do it right here if you wanted to. This new operator is actually going to be really important because we're going to use this in the lab today in the lecture, which is going to talk about inheritance and how to take this concept of classes and really just expand it in a way that makes it so that you can make really full-fledged games and write less code. Okay, so this is the example of how to actually make Pokemon using pointers, like so. And then the final lab was, I want you to change your 3 Pokemon so it uses 3 instead of uses an array. Yeah.
What does the delete do? Delete Bulbasaur, delete Charmander, delete Squirrel?
So when you call new, it asks for some memory. From RAM or from your hard drive, wherever it's actually currently has memory. So it's going to say like, hey, computer, I need something about this big. I need about 20 bytes of memory. So okay, computer's like, all right, as long as you're running, I'll give you these 20 bytes. You hold on to them. I'm not going to give them to anyone else. If you want to return that back to the operating system, you have to call delete. As soon as you call delete, you give that back to Windows so you free up some RAM. So remember the example that I gave about how like if you don't ever call delete, your memory usage just keeps going up and up. Do you remember when I did that? If I do this.
Oh, yeah.
If I just say Squirtle equals new Pokemon, and I just do this over and over and over again without calling delete, watch what happens. I'm going to bring up the task manager here to showcase the memory usage here. Can you see my memory usage there? Yes.
Yeah.
See how it's going up?
Yeah.
It's going to keep going up. And in fact, it's going to go up in a way, this is called a memory leak. If I do this, I can actually probably get it to grow. I'm going to have it go up 100 times as fast. I don't actually know how bad this is going to get. Typically, you don't want to do this.
It's over 9 now.
Oh, this isn't making it any different. It's not making it go any faster because I just had it loop true. But I can do this. And if you don't call delete, that memory never goes down. The actual memory usage of this this program that we're writing should be super tiny. Unfortunately, it's very big because of the memory leak. And so as soon as I call delete here, if I literally just call delete right after I call new, watch the memory usage now. 2 megs. Okay. All right. That's why you call delete. Now, to be fair, if I didn't call delete here, if I just deleted these things, that memory would actually go back automatically because the program would quit and Windows reclaims all the memory used by the program when it exits. So even if you don't put a delete on here, the memory will go back. But the key is you need to get into the habit of calling delete for every time you call new, because you might actually still be running the game down here. Like you might do more stuff down here, like there might be more game to run, and you don't know that. So you need to delete it as soon as you're done with it. Okay, so let's use an array here now. So I'm going to create, instead of 3 separate variables here, I'm going to create Pokemon pointer to 3. There's going to be, this is an array of 3 pointers to Pokemon, okay? And in this case here, instead of creating 3 separate variables, I'm just going to use my variables that I created earlier. Like so. And now instead of doing this, you can create a loop. And the loop only has to do this once based on the index of the array. So it's calling my Pokemon at I and calling his print info. We can get his name. So if I want to get his name, I could do this. I don't have to actually print out his name, but I'm going to show you. His name is currently private, so I cannot do this. This will not work. Because remember what we said about private variables, you can't access them because only the class that declared the private variable can use them. So how do I get access to the name? How would I actually get the name out of here? Does anyone have any ideas on how I could do that? How do I get this variable out of here? How do I get mName out of this? It's in there. What can I do to get the Pokemon name and only the name? I could delete this, which is not what you want to do. I could move this down and make this public. But again, what I said was that you want all your member variables to be private. This is a very common thing you'll run into where I want to just get the name. I don't want to change the name, I just want to get the name. And the way you do that is by you write what's called an accessor. An accessor is just a function. It's just a name for a function that just returns a member variable. In this case here, I'm going to create an accessor function called getName. And getName, all it's going to do is literally return the name. Seems kind of silly because I can get it right here. But again, this is wrapping, this is hiding away this variable so that this variable remains private. This function here is public though. This function is public and is giving you back a private variable.
So
it's actually giving you a copy. What's that?
So is it looping if you have get name and then you put return name? Is it just gonna?
No, because getName, what it does, it just returns what a copy of this variable is. Yeah, mName. It doesn't loop. It doesn't call. This would be looping.
Okay.
This would get you looping forever. This would likely cause your program to crash. You actually want to return the variable that lives inside the class. Okay. By doing this, now instead of accessing a member variable for name, I just can call this function getName.
But you can't change the number function with that variable, though, right?
I can't change the member function. Yeah, right, that's right. I can't actually modify it. Like if I wanted to change his name to be equal to like, I don't know. What's that? Pidgey? Sure. You can't do this. Remember that a function is, you can either pass an argument to a function, or you can use the return value from a function in an output. You cannot take the return from a function and assign it. This does not work. This will not compile. Okay. For deleting, it's the same kind of idea. You can use a loop here, and all you have to do is call delete my Pokemon at I. All right. Bam. Same output. Now I have a loop that prints out their CP values and their HP and attack. All right. So that's a homework.